Hello, friends. Introduction to our new subject, dynamics of machines. So, in this fifth semester, we are going to learn about the dynamics of machine. So, it's a part of theory of machine. So, earlier, which we had learned was kinematics of machines. So, in kinematics of machines, we learned about the various mechanisms, different types of mechanisms, and their working, how each mechanism works, and how it performs its actions. So, the same to that, that is now the dynamics of machines is nothing but the study of the force applied to any mechanism to give the required output. So, the study of this force analysis as well as the study of different concepts regarding the force and its movement and its angular positions. So, this subject deals with the various forces. So, this subject is dynamics of machines. So, let's start. So, dynamics of machines. So, that is subject code 18ME53. So, the course outcomes, the course objectives are to understand the force motion relationship in components subjected to external forces and analysis of standard mechanisms, to understand the undesirable effects of unbalances and precise motions in mechanisms, to understand the effect of dynamics of undesirable vibrations, to understand the principles in mechanisms used for speed control and stability control, to know the concepts of modeling mechanical systems using spring, mass, damper elements, to compute the natural and damped frequency of 1 degree freedom of mechanical systems, to analyze the vibrational motion of 1 degree of freedom mechanical systems under harmonic excitations. So these are the learnings which we are going to learn, course learnings which we are going to learn in this subject. Now, so there we have, as we know, we have 5 modules. So module 1 deals with static force analysis and dynamic force analysis. So here we are going to study about the static force analysis. So static force analysis, as I said, which is the study of force applied to a mechanism to get a desired output from that same mechanisms. So we have, so it's a completely analytical based. So most of the models are analytical based here. Then dynamic force analysis is nothing but is the force analysis, static force analysis along with the rotational movement. Next, model 2, we have the balancing of rotating masses and balancing of reciprocating masses. Balancing of rotating masses deals with masses rotating in the same plane or different planes. So here we are going to study about the balancing of machines, and balancing of reciprocating masses means which deals with balancing of a engine or a car engine or bike engine, or nothing but balancing of crankshafts. So yeah, this also is an analytical. Module 3 deals with governors and gyroscope. So governors, so we'll just learn about the governors which are used to control the speeds and all its mechanisms in this module. So about the analysis of speed also, and gyroscopes, we'll also learn about the gyroscopes and its working and its effect in this module. Module 4 we'll learn about the free vibrations, on basic things about vibrations, and the definitions of vibrations and derivations of vibrations. And then in the again in same fourth module we'll learn about the damped vibrations, which are type of vibrations and its analysis. Module 5 will learn about the force vibration, means the amount of amount of force given to a system and its output with amplitude. So we'll learn about all these modules in this introduction. So we'll start with the model 2 first, that is a balancing, one of the easiest modules, a very easiest way to solve the balancing. So first we'll take up the model 2. So first we will take up the model 2, that is balancing of rotating masses. So first we need to learn what is balancing. So balancing is a process of eliminating or reducing the forces and moments. It is achieved by changing the location of center of mass of the links. So balancing of rotating parts is a well-known problem. So as we know, balancing in rotation is very important. For mechanisms containing links rotating about the axis, which are not fixed, so force balancing or required force is required to balance it. So balancing in a rotating body is very important, just to avoid the unnecessary vibrations. So there are many methods to resolve vibration problems, or else it will lead to dangerous vibrations. So balancing is a technique of correcting or eliminating unwanted inertia forces or moments in the rotating or reciprocating masses. So it is achieved by changing the location of center of mass. So objectives of balancing are: the center of gravity system remains stationary during complete revolutions of the crankshaft, and the couples involved in the acceleration of different moving parts should balance each other. So there are different types of balancing: static balancing and dynamic balancing. So as you can see, this yellow shaft has a center of gravity CG away from the geometrical center line. So this may cause an unbalance in the shaft. The shaft vibrate violently at higher speeds. So to reduce this balance, the CG, the center of gravity CG, and the geometrical center line should coincide and should lie on the same axis. So basically there are two ways of balancing: static balancing and dynamic balancing. So in static balancing, A static balance is a balance of force due to action of gravity. For example, the old weight system which we used in shops are example of static balancing, where 1 kg of weight was put in one pan and 1 kg of rice or grains were put in another pan. So such type of balancing was called as the static balancing. A, a body is said to be static balance only when the center of gravity is on the axis of rotation. Now, dynamic balance. Dynamic balance is a balance due to action of inertia forces as well as the couples of two force. Couple formed by the two force should also be zero, negative, zero. So such condition is called as the dynamic balance. So static balance. So net dynamic force acting on the shaft should be zero. Also requires the line of action of the centrifugal forces must be the same. In other words, the center of masses should lie on the axis of rotation, as I said. So this condition is called static balancing. Dynamic balancing, the net coupled due to dynamic force should be zero. Acting on the system should be zero. Therefore the algebraic sum of the moments about any point must be zero. So here there are various cases of balancing. So these various cases of balancing are balancing of single rotating mass in the same plane, balancing of single rotating mass in different plane. Third one, balancing of several masses in a single plane, and balancing of several masses rotating in different planes. So here we will learn about all these four cases of balancing.